Hi grade 12s, this is hopefully a short video guiding you through position vectors. So last lesson you should have started to develop a bit of an understanding about direction vectors. Hopefully you had a go at this investigation. Obviously we'll all have different answers depending on where you put A, B and C. But I hope you found that at the end, going from your point P to A to B to C to Q resulted in the same vector as just going directly from P to Q. So if that didn't happen, go back and have a look, check the individual vectors, check your addition, but yeah, that should be what we find. So the key points then are that vectors A and B are parallel if vector A is a multiple of vector B, a scalar multiple. It could be that K is a negative, in which case A and B are going in different directions. It could be that K is greater than 1 or smaller than 1. The second key point from that investigation is that if we're adding vectors A to B, and then we add on vector B to C, we should end up with A to C. So as long as we're going from, we're going into B and then out of B, this idea of this triangle law works. And it doesn't really matter how many vectors we add together. It's that very first starting point and the final end point that are important. And as long as we are kind of going into and out of each point, this will work. Okay, so moving on then. Last time you were looking at displacement vectors. Today we're going to focus on something called position vectors. So a position vector is a vector that gives a point's displacement from the origin. And it's really easy to get from its coordinate, because the coordinate tells us that information already. So if the point A has the coordinate 4, 2, then the vector to get from the origin to point A is just simply to go 4 to the right and 2 up. Equally, point B, you can see we've got a coordinate of negative 2, 3. So its position vector is negative 2, 3. So it's really easy to convert between a coordinate and a position vector. Now we can apply what we just were talking about up here. We can apply that to here to find the vector that takes us from A to B. So there's many ways of doing this. One way is to go, well, if I want to go from A to B, that means one thing I could do is I could go back to the origin, because I have a way of describing that motion, and then I'm going to go from the origin onto B. So back to the origin, and then from the origin onto B. So we're going from A to O, and then O to B. And based on that triangle law, we should end up with A to B. Obviously, we have a vector that gets us from O to A. That's the vector little a. So what we're actually going to be doing is taking the negative path down there so that we get back to the origin. And that will still give us AB. And what people commonly do is they write this as OB minus OA, or as vector B minus vector A. Finding these vectors is also another easy way of doing it is purely to look at your position vectors. So here are my position vectors for A and B. And if I want to find the vector AB, what I would probably do is just think, well, how do I get from the X position of my position vector of A to the X position of B? I'm going from 4 to negative 2, so I am subtracting 6. And then I do the same for the Y positions, going from 2 to 3 is 1. And that vector should get us from A to B. So if we have a look here, I am going 6 to the left, 1, 2, 3, 4, 5, 6, and then 1 up. So while this is useful, when you actually have the coordinates, often it's easier just to I certainly find it easier to just think about how do I get from this point to the next. Okay, so there's an example on the next page. By all means, pause the video, have a go, and then if you want, fast forward and find the solutions, or go onto OneNote to find the solutions. So part A, find the vector AB. Well, we've talked about that just now. We said it was going the wrong way down OA. So I want the negative of OA plus the positive of OB. Okay, and these are the same points. Are they the same? No, they're not the same points. So here we are. OA is 6, 1, and OB is negative 2, 5. Okay, so I want the negative version of 6, 1. And then I want the positive version of OB. And then I can combine them. And I've got my vector AB. Of course, we could have done that just by looking at the coordinates and thinking, how do we get from A to B? Point C has coordinates 7, 4. So OC is 7, 4. Find the vectors AC and CB. Okay, so I think for this one, I'll try it the other way. I'll try just thinking, how do I get from position A to position C? So I can see that I want the X to go from 6 to 7, and I want the Y to go from 1 to 4. So that's how I would get from point A to point C. And I find it a quicker way of going through that rather than having to write out like the vector calculation. We can just go straight to an answer. Okay, we also need to find CB. So once again, I would probably just think to myself, how do I get from C to B? If you find it much simpler to use that calculation of negative OC plus OB, then by all means do. I can see I want to go from 7 to negative 2, so I need to go negative 9. I want to go 4 to 5, that is going up by 1. Okay, use the triangle law for a vector addition to write down an equation linking AB, AC, and CB. Okay, so looking through these, I can see that if we're going to use the vector addition law, we want to go into a point and out from that point. And looking at the three vectors AB, AC, and CB, I can see that C is at the end of one of these vectors, AC, and it's at the start of another, CB. So going AC plus CB should get me from A to B. So AB is equal to AC plus CB. And the next part of this question lets us check that. So part D says verify your answer is true. So let's make sure this works for our values. So AC plus CB, I found those both in part B, 1, 3, and negative 9, 1. If I add them together, I get negative 8, 4, and I can see in part A, that was my answer to AB. Good, that's checked that works. Okay, finally, the point D is such that A to D is 5, 2. Find the coordinates of D. Okay, a couple of ways we could try it. If I've got point A and point D and the origin, I've already got a vector that gets me from A to D. I already know a vector that gets me here. And what I want to find is the position vector of D, because that will let me know what the coordinates of D are. So looking at this, trying to link it to that vector addition calculation, I could say that, I don't know, I'm going to start with OD, because that's the thing I really want. I could go from O to A plus A to D. Now, I know O to A, sorry, is, where was it, 6, 1. And I know AD from the question is 5, 2. Okay, let's just move this out of the way. All right, and then I want to find OD, so I'm going to add those together and I'll get 11, 3. So the coordinates of D are 11, 3. Folks, do take a look through the homework. It is generally fairly straightforward. At this starting stage of vectors, I would encourage you to stay completely up to date with the homework. You'll find as we move on with vectors, we really need to get comfortable with the idea of position vectors, displacement vectors, finding vector AB given the positions of A and B. So really trying to make sure you're up to date will help you as we move on in this unit. All right, I think I'll see you later in the week.